Hello everyone and welcome on this talk when we are going to talk about the bad guys and the good guys in the embedded field. My name is Marta and I'm an official security person with PhD in security, but I prefer to stick with developers. So I try to talk without dialect, if I do not talk with security people, of course. And I bring chaos, and I talk a lot at conferences. You may have been at other of my presentations at some point. So, a good presentation without stories, that doesn't exist, right? So let's go directly to stories. The first one, have you ever wondered what if your vacuum cleaner spies on you? And in fact, that's a real story. The big vendor of vacuum cleaners had a problem. They had an app that you could use to access the video flow on the vacuum cleaner. And the thing was that the authorization, the PIN code to access the video flow was only checked in the app. So with the correct HTTP request, everyone could get to that video flow. But that's not. But bugs happen, right? That happens. But the funny thing is that the product was security certified. Even better, right? So it's a pretty funny stuff. I give you a link if you can watch the videos, because there are videos of the whole story, how they managed to demonstrate how it works. And it was actually used in real attacks. In addition to the camera, there was a microphone, and there was some people who wanted to make fun, who were playing profanities at people's vacuum cleaners. Another story. Network routers. Who has a network router at home? Yeah. So network routers are a really popular target for attackers. So one example here, there are a lot of other ones. This one is a firewall that got actually attacked to spy credentials in the network it was expected to protect. Nice. Or, well, ATM, I think that some of you already know what it is, an ATM. Something that you need to use if you do not pay by your phone or whatever. So ATMs are targets of attacks for many years. In the 2000s and 2010s, the attack consisted of opening the ATM, inserting an installation CD to the PC that was hidden in there, and booting malware. Those days, it's more an USB key with malware. The same thing, you open the thing, you put the USB key in there, and there's malware. And then the criminal gangs have some special combination to type on the keypad, so then it gives them money. And in some cases, even it works in such a way that it only works on Sunday afternoons or Monday afternoons. So yeah, we have also funny things like that. And another variant is to get through the ATM to an SSH channel from the bank network. I'm not giving comments about security of the whole thing. So, okay, though we have those funny attacks, but why? Because there are security researchers who want to try to attack certain things, but they do it for research. They are people also who do that for other reasons. And what are the other reasons? First, there are two types of attacks that you have against your systems. The first type is untargeted. Untargeted means that they want to have access to some systems. They do not target your system explicitly. They just are running a generic exploit against a generic bug, and they just want to get to something. It doesn't matter what it is. And there are people who just do it for fun or prestige, to show up how clever they are. They can get into a system. Those are usually the less dangerous. And then you have the whole market of botnets. In fact, a denial of service attack is sold as a service. You can buy denial of services as cheap as for 10 euros. And why would you want to do a denial of service against someone? In fact, there are many reasons. There are people who want to shut down a website or network of their competitor. If there is a ransomware in progress, some people will run a denial of service at the same time to bring even more chaos, so that the reaction to this ransomware is slower, and there are more chances to grab the ransom because the company finally decides to pay because they panic. Then you can also use botnets to tunnel traffic containing other things if you do not want it to go out at the place it would be. And something that struck me when I read about it long time ago. Do you know online gaming? You know. Would you be ready to pay for a denial of service against the other player so that they kicked out of the server? And it's a real market. People are really ready to pay for that. It's funny or scary at the same time, I don't know. Okay, and there is cryptocurrency mining. If your embedded device is a little bit more powerful, it may be used just as a server for cryptocurrency mining. Then you may also have targeted attacks when you are the real target. It's no more we are going to get on someone, but we are going on you. So in this case, a ransomware, the first type, typically it attacks the main network, but there may be the second part of the ransomware attacks against, for example, industrial installation to shut everything down and ask for ransom for that. And that usually requires knowing what industrial controls are there in this installation to be able to run the right exploit to shut everything down. And possibly wipe down the firmware also in the process. Related to that, breaking infrastructure, for example, wiping out the flash content of the device. There were many examples of that at the beginning of the Russian-Ukrainian war. You may have heard about an attack about the satellite access network when they were wiping down flash of the satellite modems to shut down infrastructure. But it also happens against competitors and in many for many different reasons. Then there's spying. So someone gets to an installation to get the customer information, the formula of the product, or some chemical formulas, or some other information like that. And it's not necessarily you that is the final target. They may be attacking you to grab information to attack someone else. And finally, there's theft. So in many cases, you can just try to break physical protection to get the device, like break a car, to get it, to make it perform an action like the ATM. If there's some confidential code on the device, try to get it. There are many possible cases here. And how has it changed over time? I have had a look at the presentation of Jake H from 2009, and that's one of the slides of the presentation. The wording is pretty similar. And what I note down is that even at that time, embedded was a target. That's not a real surprise. All attacks that Jake has mentioned in his presentation, they still exist today. There are more. And the procedures to identify what can happen, they are also the same. But there are things that changed. So our devices got more complex, and what was an attack on the main component of the device, those days is frequently an attack on the component. Let's say on a Wi-Fi chip. So you had a packet that could crash the main device. Those days, it's an attack that crashes the firmware running on your Wi-Fi chip. And the difficulty for embedded developers is quite frequently you do not have access to the source code of that firmware that may be attacked, and even if you see a crash, it's quite complicated to do anything. Then we have a new class of attacks related to apps. We have apps that frequently control our devices, that adds an additional communication channel from the device, frequently to the vendor server and to the app, quite rarely directly. And we have that communication, but we also have the user data and the device data stored on the vendor server. And that's a really nice target if that vendor has sold a few millions of devices to grab the user data, not from devices, but from the vendor server. Okay, and if you are an embedded developer, you may be asking yourself a question, but how can they attack my device? And some developers are telling me that, well, they do not know what the attackers may want to do. They do not have that crazy imagination to figure out what the bad guys could be doing. And on the other hand, I've heard that also, that under the CRA, secure boot is mandatory. Maybe. In your case, it depends. Yeah, clicker didn't work. And another question I'm hearing, Marta, please give me a to-do list that I have to do to be compliant with the CRA. And what we are going to do right now, I will give you not the list of that you have to do under the CRA, but the method to get your list for your device. And this method of getting a list is called risk analysis. So there are many frameworks of doing that. I'm simplifying. Sorry for the security people. I'm not using security dialects to name many steps and part of the procedure. I want to make it easy to understand because it's a good engineering practice in all cases. So comment just here, the CRA says that you are obliged to have a risk analysis, but it doesn't tell you, doesn't impose you the framework to use. So you use whichever framework you want, but you need to have the result. As you can see, already a hint, it's a turning process that never ends. We love infinite loops. So, what you need at the beginning is the product scope and the assets. So the product scope is what does your product actually do and what it doesn't do. In fact, having that is one of the other requirements of the CRA not related to the risk analysis. So you need to have that. And what you also need are the assets. And asset is what is there in your device that you want to protect. Because maybe there's not everything that you want to protect. Depends on the device. Let's go to a few examples. Examples of things that you may want to protect in the case of a router. The integrity of the data your user is sending, right? You do not want to allow someone to modify the data our user is sending. The confidentiality of the network information. You do not want people to modify and to read what our user is sending, and there may be some personal data of our user stored in the router, like passwords and things like. We do not want the attacker to have access to that. For a vacuum cleaner, the short list I have is an extract from an exercise I did with one team I trained. You may not believe me, but we got we got a pretty long list of assets of a vacuum cleaner. So we have the video stream. You do not want someone that's not authorized to access the video stream. The audio stream, same thing. The plan of the house, the vacuum cleaner is running. You don't want anyone to access it. There is health of the user of the family. So the vacuum cleaner theoretically can do some damage if they run into someone. They can hurt them. So that's an asset you want to protect. And the property, like they may run into some furniture and break it. Yeah, we went a little bit crazy with the vacuum cleaner, and that was just the beginning. And then when you have the list of the things you want to protect, then the second step is to analyze what kind of threats. So what can happen? What bad thing can happen? The simple option I use typically at the very beginning, I just put the whole team in a room and I tell them to brainstorm and to list down everything they think about that could go wrong with this device. You will be surprised how many crazy things this is going to show. And I tell them, list everything, no matter how improbable it is, just list everything. And in fact, it's also pretty accurate. I usually have all the main points from that exercise, but we can do it in a more structured way. So we work on an attack surface. What is an attack surface? That's the second and the last term that I'm going to introduce. That is all of the ways by which attacker can get in. So the attack surface are all of the external interfaces. So all your USB, Ethernet, screen, keyboard, power supply, everything. The remote control, if it's the off course, the controlling app of course, and you review all the data flows that are happening. And also, one funny thing is reviewing your software blocks to see which teams developed what. Why? Because typically, if you have an interface between two teams, there are bugs in there. A small example. So we have a vacuum cleaner that is there with a kitten. Our vacuum cleaner has a Wi-Fi, Bluetooth, USB, and LiDAR to find its place. Through the Wi-Fi, it is in the network, in the home network. There are some other devices in your network, and there is a router giving access to the internet. Through this Wi-Fi router and the internet, it's accessing the vendor server and then getting to the control app that you have on your phone that can also communicate with the device through Bluetooth. Of course, that's only one of the possible data flows that you have. Having such images, it allows you to imagine things that can go wrong. So, example risks for the vacuum cleaner. The attacker could hack into the vacuum cleaner and use it to attack all the devices that you have at home. Possible? Yep, if they manage to do so. The attacker can stream the audio and video from the cleaner without authorization. That was the case of the story that we have. Also, it's a risk. The attacker could also move the cleaner around the house, so for example, damage the property, film the house, and get the data out of it. That's possible. On the other hand, the attacker may also be interested and get to the vendor server, grab all the data that has been transferred to the server, and do not touch the device itself at all. And finally, the attacker may change the firmware on the cleaner to do things that they want to do. And when we did our exercise, that was just the beginning of the funny things that we have imagined. So yeah, so you are getting a lot of funny, crazy ideas, and how to deal with that directly. So there are two things that each of those threads, so each of those scenarios has. There's a probability. So what is the likelihood that it happens? And the other thing is the impact. So if it happens? So how high the impact is going to be? From, well, it does nothing, to it's a total destruction, passing through some partial damage. Typically, we use a numeric scale for both of them, either from 1 to 3 or 1 to 5. If you have really many risks, you may use a 1 to 10, for example. Depends. What we do not want to have at the end, to have 30 risks with the same numerical high value, because you cannot create a priority list out of it. And then, yeah, you create a matrix, you evaluate likelihood, impact, you calculate the values for all of your threads, and you sort your list. You can also nicely place them on a diagram in the slide deck for the management. So for the vacuum cleaner example, let's say during the brainstorming, we assume that the problem of the attacker is streaming video without authorization. The possible impact we estimate is 4, so it's something pretty serious for the reputation for the vendor, but also for the user. And the first analysis of the team is the likelihood of 2, because they think it's that they have put the pin code and that should be fine. So then we have a look at the source code of the project or in the more detailed documentation. And for example, during the first analysis, we figured out that The app part was done by an external contractor with no maintenance contract, there's no tests, and this app was written in a language nobody in the project can write anything. In this case, we'll probably increase the likelihood of problems happening with this part. And we can do that analysis for every single item we have on the list. And now I have a sorted list at the end. And what I do, I find actions. So I take only stuff that is at the very top. If you have a nice technical feature that applies to the item that is at the bottom, you don't do that. You take only the things on the top, and then you either eliminate them or you minimize them. So you find what you can do to eliminate it. For example, this vacuum cleaner has an USB interface and there's a chip that has problems. This USB is problematic. The question can be, can we disable that USB interface totally in the production device? If we can, just disable it, done. The similar actions is adding encryption for some data transfers if there was nothing. We can also minimize risks. So if there is a module that you find risky, you can do a security review of this one, have a code review, and fix issues that you can find so that you can increase the confidence of the team in that security module, and then it decreases the risk. If you have a risky library with a lot of bugs and CVs and whatever, then you can maybe change that library to something better supported. And typically, for each product, there's some value of accepted risk that has to be agreed. So you do not address anything that is below the accepted risk. Okay, let's bring everything together. So this is a circular process. So after you do your fixes, you recalculate the likelihood and the impact, and you may redo the whole thing yet again. I highly recommend to document every step because the regulation about this will want that. And what is important, to review that document regularly, especially if you are adding new features, because the list may change. Then review it periodically, just to make sure that it's still up to date. And it's normal that you will learn about new vulnerabilities, new types of attacks, and then you can add it to the list. It's normal that you change it regularly. It's not set in stone. It's a living document for the discussion. And when you have that document done, or when you start working on it, make sure that everyone in the development teams knows that it exists. Because in a good development team, that's a document that shows all of those assumptions that have been taken. And it's something that new team members can learn a lot of about your product. Some resources for you to start. I like the ENISA's Interoperable EU Risk Management Toolbox. It gives you lists of scenarios and interfaces to have a look. This is the shortest risk management framework that exists according to my knowledge. So, good thing to start. NIST has well-known guide of conducting risk assessment also. And if you are in the ISOs, there's 27001 and 27005 if your company has access to that. And there are others. There are many others that exist. So, how many of you already have a risk assessment for your embedded product? Okay, it's a little bit more than I expected. Good. And how many of you are willing to try the exercise of 3 hours to do it? Maybe, yeah, maybe. The risk assessment, you can do it of any length. In like 1 hour or 2, you can already write the first version. A good complete that takes a week or something like that. But you can already have the first list in an hour or so of brainstorming in the team. Do not forget to bring sales and quality in, because you may learn a funny thing. It's also frequently an interesting opportunity to talk about things about your project that you have never talked with people about. For example, what your customers are. You may learn really funny things. So, to sum up, attackers target embedded devices for really many reasons, and for directly. So, you are the target, or indirectly, someone else is the target. There are millions of embedded devices out there, and many of them have similar issues, similar fixed vulnerabilities, and that's why attackers can try to run the same thing amongst different internet types. And especially internet connected devices are easy targets for a valid reasons. And I'm also including all of those devices with a 4G or 5G modem that has been added as an afterthought because we need some telemetry. Yeah, I'm talking to you. So, and when you are implementing protection, the risk management approach is the only one that works because you cannot make a 100% secure project. And it allows you to choose methods, choose solutions that actually will work for your project, to structure your discussion about what you are implementing and about what is actually important in your product. You may figure out that you do not need secure boot. You may figure out that it doesn't make sense to do physical protection when someone is opening the device, but it just depends on the device. And for one device it's true, for the other it's not. It depends. There's no size fits all. And we have like a few minutes for questions. So, yep. Oh yeah, try to ask the question like that. Yeah.
You said something about acceptable residual risk. In functional safety, there are guidelines. It's not simply that you make it up. So there is a discipline to decide whether a risk is acceptable or not. In this field, the CRA or other norms, do they provide guidance about which risk is acceptable?
So the question is if that in the functional safety there are clear guidance about how to define acceptable risk and how it's on the CRA. According to my knowledge, the CRA doesn't say clearly. The CRA says that you should take the risk into account, but it doesn't give you a guideline on what it means acceptable risk. I would assume that it's going to show up in some of the standards, but I do not know yet. Other question? Yeah.
For untargeted, okay. easy. For untargeted attacks, you mentioned a few reasons why people may want to take control of millions of devices. Do you know if the recent rise in effectively DDoS attacks from AI crawlers go through botnets like that, or is it mostly large-scale VPN?
So the question was, yeah, we have the question in the recording. I am not aware of research if the AI-related attacks go through botnets, but I would assume that it's going to come soon. I have shown in the presentation Monday, I have shown an example of research of creating exploits automatically from vulnerability information. And I would assume that some people will rapidly try it out to massively generate exploits and massively test it around just the IP ranges available. It's too cheap not to try out.
Just a comment on that. A lot of AI scraping is obfuscated. So I wouldn't be surprised if they were working through botnets.
I don't have enough information, so I cannot say. Next question. Oh, yeah, we have still time for one. I think you need to speak up loudly.
So you mentioned that it is an iterative process, so that you need to consider new attacks. Let's say you're working with a team that is not that familiar with security and up to date with security things. Is there like a cheat sheet or something to get like my device has a battery? These are possible threats, attacks that I need to consider with my team. So just some guidelines or cheat sheets to get like a better understanding of what is possible or what are the current attacks going on.
The question was if there are some guidelines about which attack types are possible about for each type of device. So the ENISA guidelines gives you kind of a list that can inspire you. Much depends also on the customers that you have. That's why I said it's good to check with the sales team, because it is well different between you sell only to end customers, to individuals, then you sell to big companies. In this case, your device may be a vector to get into the network of that big company. So there are additional things to have taken into account. So grabbing enough information, that's usually giving hints.